Okay, Chapter 3, Section G, dot 1, page 98, reading. Give two examples of things that grow exponentially. So there's a couple examples here on page 98, I mean, we can put things like money in the bank. Money in the bank grows exponentially. We could put bacteria. Okay, grows exponentially. Give example of two things that decay exponentially. Maybe we could say, you don't have to put things in the book, you could make up things. Things like value of money. And the other thing might be radioactive material. Okay, that's usually the example that books use a lot. And then they give a problem here, which is a typical problem. It's a population growth problem. So if you have 100 mice that grow 20% per week, show how to calculate the population each week. So the subscript here, P0 for example, is the week that has passed. So P0, which is the initial population, is 100. And at the end of the first week, we should say that it would be the initial population times 1.2. Okay, and that would be 100 times 1.2. Okay, and then the second week would be the first week's population times 1.2. And that would be 100 times 1.2 times 1.2, which is equal to 100 times 1.2 squared. And then P3 would be P2 times 1.2, which is equal to 100 times 1.2 times 1.2, which is equal to 100 times 1.2 to the third. And then P to the n, we could say, is equal to 100 times 1.2 to the, and you can see that the subscript here is the same as the power here, so we could say 1.2 to the n. Okay, and so now let's take this first problem here and try to graph it here. The weight WT of bacteria in a culture T hours after establishment is given by W sub T equals 100 times 2 to the 0.1 T grams. Find the initial weight. Okay, well the initial weight would be the weight at T equals 0. So it would be the weight at time equals 0 is equal to 100 times 2 times 0.1 T, which is 0. Okay? So we could put 0 here. And 2 to the 0 is just 1, so the initial weight is 100. Okay? Find the weight after 4 hours, 10 hours, and 24 hours. So we could just take the quantities of time, 4, 10, and 24, and plug those in, and then that should give us the weights. So the weight after 4 hours is equal to 100 times 2 to the 0.1 times 4, so it would be 2 to the 0.4. So 100 times 2 to the 0.4. W10 would be equal to 100 times 2 to the 10 times 0.1, which would be 1. So that's easy to figure out. We don't need the calculator for that. It's 200. W24 is equal to 100 times 2 to the 24 times 0.1, so it would be 2.4. Okay, and then sketch the graph of WT against T using the results of A and B only. So we have 4 points. We have 0, 100. We have 4, something. We need to figure that out. We have 10, 200. We have 24, something. We need to figure that out too. So let's use our calculator and figure out 2 to the 0.4 power, 2 to the 0.4 is equal to 1.319. I'm going to multiply that times 100, and I'll get 131.95. 131.95. 131.95 is 132, right? 2 to the 2.4. 2 to the 2.4. 5.27. I'm going to multiply by 100. 529. Okay, so let's try to graph this here. So one of our points is 0, 100. Let's say 1, 200, 300, 400, 500. Let's say that this is 100, 200, 300, 400, 500. So it's 0, 100. I'll mark that here. 4, 132. So let's say this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 4, 132. 4, 132. 10, 200. 24, 529. 529 would be about there. Okay, and then, okay, so it would be about like that. So that was C. Now use technology to graph y equals 100 times 2 to the 0.1x and check your answers to A, B, and C. Okay, so let me teach you how to use a calculator to do this. You use y equals, and then you just program the formula in here. So you put 100, 100 times 2. To do times, you could just put times, or you could put just put the number next to it with the parentheses. 2 to the 0.1x. 2 to the 0.1, and x is this button here, and then parentheses. And then you can graph it, and you can see it. Now this, my window is kind of weird, so let me change the window size to the regular size. So I'll do zoom. Zoom standard is 6. That's what you should always start with. Okay, and then, okay, let's check our answers. Well, to check our answers, it's better to use tables. So we do second table, and actually the first window size I had was probably better. The zoom standard doesn't show these big numbers, does it? Okay, so let's check our numbers. For example, we had t equals 0. Yep, it's 100. T equals 4, 132. Yeah, that's right. And then t equals 10. $200. Yep. T equals 24 is 529. Yep, 520. Actually, they have 527.8. Their 24 is 527.8. It's 528 actually.